Hello, this is Brother Krumar from the Math Department, and now I'm be covering Lesson 19, Part 2, and primarily dealing with hypothesis testing for two proportion. Alright, so now before we get into that, I just want to review a little bit in terms of the different types of null and alternative hypotheses that we dealt with. Way back in Unit 2, when we dealt with one sampler, one mean, sigma known and unknown, the null hypothesis was mu is equal to some value. It could be any value, and the alternative hypothesis was either mu is not equal to a value, or less than the value, or greater than that value. Okay. Now with independent samples, I put this in here because of what we'll cover in just a moment here. But the null hypothesis is that the two independent means are equal. Okay, and the alternative hypothesis is either that they're not equal, one is less than the other, or one is greater than the other. Okay. Now I compare and contrast what we're doing in Unit 3, which is, first of all, with one proportion. If you compare one proportion to one sample, sigma known and unknown, the only thing that's different between the two is that we have the means being, we use population mean, which is mu, and we use a population proportion down here, which is p. Similar to comparing independent samples versus two proportion, where we have the population means, or mu's, versus what we have down here, which is the population proportions. So the null hypothesis for two proportion is that P1 is equal to P2, and the alternative is three options: is that the proportions are not equal, or one's less than the proportion from one group is less than the proportion from group 2, or the proportion from group 1 is greater than the proportion from group 2. Okay, so here are the 5 steps for doing a hypothesis test for two proportions. So stating the null and alternative hypothesis, it's kind of redundant here, but I list the null hypotheses twice. This is how we state it. The null hypothesis is that the proportions are equal. And then here are the 3 options for the alternative hypothesis. We compute a test statistic. Now notice here, then this is a bigger formula for a z-score compared to one proportion. Where what we do is that we take the sample proportion from the first group minus the sample proportion from the second group, minus, and then we take the population proportion from group 1 minus the population proportion from group 2. But notice here, since our null hypothesis, this is referring to the null hypothesis, but since we're saying that the null hypothesis is that the two proportions are equal, these values here cancel out. Okay, and so that's the numerator, and then the denominator we divide it by p hat minus 1 times 1 minus p hat divided by 1 over n1 plus 1 over n2. Now p hat, this is a different p hat than what you're used to seeing. P hat originally that you've seen is just taking the number of successes divided by n, x divided by n. But here now p hat is what's called a pooled proportion. So it's taking the successes, or the successors, or the people that say yes. For instance, in a sample, we want to see it, the number of people that vote for Barack Obama in males versus females. So x1 would be the number of people that vote for Obama. x1, x2 would be those who, or x1 would be for the females, for instance, and x2 would be for the males who vote for Obama, and n1 and n2 would be the two sample sizes from both groups. Okay. Now we can do this by hand if you'd like, but as I mentioned, with the confidence interval, it's a little unwieldy. So what you can do is that you can use this tool again in Excel to calculate your test statistic, as well as the next step, which is getting your p-value. Okay, so then that's what I'm going to do as well too. And then step number 4 is to actually, before going into step 4, we'll also ask you to the test statistic and p-value to be illustrated in your work, where you'll sketch the test statistic and shade the p-value. And then step number 4 is, and step 5 is the same thing. If p-value is less than the level of significance, we reject the null, and if not, then we don't reject the null. Okay, and then we state our conclusions based off of whether or not we reject the null hypothesis. Okay, and so like I said before, step 4, we always refer to the null hypothesis, and the last step we refer to the alternative hypothesis. Okay, so let's go through a couple of examples here. So is the proportion of men that taste PTC different than the proportion of women? So based on a recent study done by Elise Johnson, she found that out of 66 females, 51 could taste PTC. And out of 52 males, 38 could taste PTC. Tests that claim that the proportion of men and women who taste PTC is different with the level of significance of alpha equal to 0.05. So step 1 is state the null and alternative hypotheses. The null is that the proportions are the same. Okay. And the alternative is that they're different. So notice at least wanted to know if whether or not that there is a difference, just a difference, not that one is greater than the other. So the alternative is that P1 is not equal to P2. So step 2 and 3, what I'm going to do is I'm going to input this information into my Excel. So what I'll do is I'll take for the first group, there's out of 66 females, 51 good taste PTC, so I'll put that in here, 51 and 66. And then for the men, it would be 38, and then 52. And then when we calculate that, we get a test statistic down here of 0.526 with a p-value of 0.59. Okay. Now, if we wanted to label, now we can label the test statistic in shade using the applet. Here's a representation of the applet here, where if we put in 0.526 down below and press enter, and then we shade on both sides, this would represent our test statistic in the distribution of a sample proportion, and then this here, the shaded area, would be the p-value. Okay, and so since the p-value is greater than alpha in this case, we do not reject the null hypothesis. So therefore, we have insufficient evidence to say that, excuse me, I'll say that again. We have insufficient evidence that the proportion of men and women who can taste PTC is different. Okay, so let's go through one more example here. And what I'd like for you to do is that I'd like for you to stop the recording, go through this problem. This is also in the online textbook. See if you can do this on your own, and then we'll go through the answers. Okay. So let's go through this here. Some people have claimed that the mortality rates are higher for patients admitted to a hospital on weekend compared to the patients admitted on a weekday. The problem is that the quality of care in the emergency care facility may differ at different times of the week. Doctors Bell and Riddlemeyer hypothesized that the probability that a patient with an aortic aneurysm will die is greater if they are admitted in a hospital on a weekend compared to a weekday. Out of those 4,145 patients admitted during the weekday, 1,476 died, and out of those 1,309 patients admitted during the weekend, 553 died. Test to see if there's a lower percentage that died during the weekday versus the weekend with a level of significance of 0.05. So step 1 is state the known alternative hypotheses. And since we're looking to see if it's a lower percentage, we're going to do a one-sided test here. Okay, so the null hypothesis, as always, is that the proportions are equal, and the alternative is that it's less than. Step 2 and step 3 is get the test statistic and the p-value. So what I'm going to do is I'm going to go to the Excel again, and I'm going to type in, let's see, so I'm going to do weekdays, so it'll be, let's see, it'll be 14. I'm just going back and forth there, 1466, I believe, or excuse me, I should start that again, 1476, and then it's divided by, and then the sample size is 4145, okay, and then for the second group, it's going to be 553 out of 1309, okay, and then I press enter, and then down below here is where I get my test statistic. We're doing now, I can change this up though, it's not going to change our results here, it's going to be a one-sided test. So notice here, since the p-value is close to 0, I'm still going to get the same result, but this is where we get our test statistic and our p-value, okay. So then, I'll just go back to the slide here again, so here is our steps. And then step number 4, p-value is less than alpha, since the p-value is close to 0, so the null hypothesis is rejected. So we have sufficient evidence that the lower percentage died during the weekday versus the weekend. And then the next item here is how you can label your test statistic and shade your p-value. So I use the applet again, and I notice here is because we're 4 standard deviations or beyond 4 standard deviations away from the null hypothesis, you can barely see shading. So I note here that you shade on the left, and then you have the test statistic negative 4.331. Okay, so then the last slide is the requirements to check through the 2 proportion procedure for doing a hypothesis test, and it's basically n1 times p hat 1. So p hat is our sample proportion, and if you multiply those together, and it's greater than 10, as well as n1 times 1 minus p hat 1, that's also greater than 10. Then the requirements met for the first group. And then you do the same thing for the second group. Okay, now what you can do to check that is, let me escape out of this, if you go to this area here, you can see whether or not all of those requirements met. You can see all of them are above 10, so the requirement is met. Okay, to the descriptive statistics, there's a sample proportions. You can get those sample proportions here. Here are the 2 sample proportions. And also, you can do pie charts and bar graphs. I promised you I'd show you an example of that. And here's an example of pie charts and bar graphs. These are from SPSS. This is from the previous study done by Elise Johnson with PTC paper, and this is how it would look for a pie chart, and this is how it would look like in a bar graph. And so that concludes the video for dealing with two proportions for lesson 19.